Okay, so today we're going to talk about 9.5, solving systems of linear inequalities. Okay, so there are certain things about inequalities that we have to go over, and we'll jump right into it right now. Essential question of the day. How do you solve a system of linear inequalities? Well, graph each linear equality. So whenever I see an inequality, automatically I'm thinking graph. And when I'm thinking graph, what? That's right. Slope-intercept form. So linear inequality in the system on the same coordinate plane. So I'm going to have how many of these? At least two, because I'm dealing with a system. All right. On the same coordinate plane, the solution of the system is represented by what? Overlapping, or what we'll call double shaded areas. Okay. Vocab for the day. Let's talk about greater than, less than, because we're talking about inequalities. So you've already dealt with the equal sign. That's great. But now let's talk about greater than. Greater than, we read from left to right. So therefore, greater than is going to be this way. Less than is going to be this way. Now, let's talk about some other symbols that would sit there and help us out with this. Let's say 4 is what? Greater than what? 3. That's real simple. That's true. But 4 is not less than 3. That's not true. Does that make sense? It would be 3 is less than 4. Good. Now, when graphing, we need to know something. If I was on a number line, just straight this way, if I had greater than, I would not include whatever I'm talking about. Or I put an open circle, okay? If I have less than, then on this, I would put what? An open circle. So now, if I'm talking about doing it on a number line, how do I do it if I'm graphing it? Well, the lines that you create when you graph are going to be dashed for both greater than or less than. So you have to remember that. Okay, so if I have greater than or less than, that would be open circle, correct? Or my lines are dashed, meaning that wherever that line is, those values are not going to make the equation true. Does that make sense? We'll get into it. We'll make sure that you understand that. Okay, so it's not just about greater than or less than, but we also have what? Greater than or equal to, lesser than or equal to. So what does that look like? Greater than or equal to. We put a line underneath. Less than or equal to. In math jargon, if I'm putting it in a computer, it would be greater than or equal to, less than or equal to. So be aware. Make sure you understand that. Just has to write it out. Now, if I was on a number line, what would happen? I would have a what? Closed circle. If I was on this one, it would be a closed circle, meaning that the value is included wherever I am. So now what happens if I'm doing a linear inequality, which is some sort of line? Well, you guessed it. Greater than or equal to, less than or equal to, we have a closed circle for a number line. But if we're going to graph, we get a solid line. A solid line. A solid line represents the fact that the coordinate pairs along that line are part of the solution. So let's talk about shading, because whenever I have a linear inequality, I need to know that I must shade because there's more than one answer. So let's give us something simple. Let's say that y is greater than x plus 1. What's my slope? 1. Okay. What if I just treated this like it said equals y equals x plus 1? you would know that your b is equal to 1, your m is equal to 1. Therefore, your y-intercept is what? 0, 1. Your slope is what? 1 over 1, which says go up 1 to the right 1. So let's graph that. Put that there, put that there, put that there, put that there. 0, 1. Well, here's 0, here's 1. I would put a dot. My slope tells me to go up 1 and to the right 1. So 1, 1. And now I would make a line. Now, here's the thing. Before we draw that line, let's step back. What kind of inequality do we have here? Just greater than. So is it going to be dashed or is it going to be a solid line? If you said dashed, you would be correct. So when I draw my line, it needs to be dashed. All that does is alert me that those points along that line are not part of the solution. So let's talk about shading. Draw yourself a vertical line on your newly formed line. So here's the blue line. I'm going to draw a vertical line on it. Okay? And this will make your life really simple now. Here's an arrow and here's an arrow. Which one is telling me greater than? Is this down arrow saying greater than? No. Up arrows mean greater than, correct? So what side of the line am I going to shade? Everything that's on the side of this up arrow. And you just shade it like this. Okay? Solutions of a linear inequality. Well, remember, it's a system. So how many lines do we have? We just went through shading. So let's say that we have a graph. And with that graph, we have two different lines. One line, and you should be able to tell these attributes. That solid line means that I have either greater than or less than, greater than or equal to, or less than or equal to, because it's solid. Now, depending upon where I shade will tell me if it's greater than or less than. So since I am shading with this yellow above the green line, okay, that automatically tells me that I know that this green line has to be a greater than or equal to deal. I don't even care about the equation right now. I just want, you should be able to pick this out visually, okay? But remember, there are two different lines. So let's say we have another line that goes like this. Now, as you can see, it's dashed. So I know I'm dealing with greater than or less than, okay? Now, depending upon where I shade will tell me if it's greater than or less than. Now, I am going to shade all of this. Okay? So what was it? Yep, it was below the line. So I know that this was a less than equation. Okay? So what is the solution of my problem? It's where you see double shading. And that double shading turns into what color? Red. Now, not all of yours is going to turn into red. Okay? But as I go through here and I'm looking, you should be able to shade with black and make sure that it makes sense where I can see it should be darker where it's double shaded. Okay? So your solution is where it's double shaded. Because if you look here, here's yellow, but yellow makes the green line true, but it doesn't make the red line true. Here's purple, it makes the red line true, but it doesn't make the green line true. And then we have this red area, it makes both the red and the green line true at the same time. Okay? Solve a linear inequality system by what? Graphing. So anytime you see these, for the most part, you're going to see us graph, okay? So now, here's our inequalities. Y is greater than 6x minus 5. Y is greater than negative 4x plus 7. So a couple things we can tell right now. What kind of lines are we going to have? That's right. It's going to be dashed. Okay. This one's also going to be what? Dashed. Does that make sense? But what format are both of these equations in? Yeah, just slope-intercept form. Instead of having an equals, it has a inequality there. But you can treat it for the purposes of graphing like an equal sign. So let's do the first one. So here's the first one. Let's say y is equal to 6x minus 5. Well, I don't have to do any math. I already know that this is equal to y mx plus b. My b is negative 5. My m is 6. So my y-intercept is what? You got it. 0, negative 5. My slope is what? 6. Right? I can make it into a fraction by putting it over 1. This tells me to go up 6. This tells me to go right 1. Can I graph that? Yes, we can. So let's find 0, negative 5. Okay, so here's 0. Here's negative 5. And I'm able to put a dot there. Then the slope tells me to do what? Go up 6. 1, 2, 3, 4, 5, 6. And to the right, how many? 1. And that's where I put my second one. We already said what kind of line we're going to get, right? It's going to be what? Dashed. So if I draw a dashed line all the way here, remember a line continues on forever and ever and ever and ever and ever. Okay, so there's my dashed line. All right, now I told you to draw a vertical line. You can use the y-axis because it's vertical, but sometimes people get confused with that, so I just make a little mini one right there. Okay, and I put the arrows there, right? So there. Now this says what? It's the first one. Greater than. So which one am I going to do? This arrow right there. So everything above this line gets shaded. Now you don't have to go crazy with the shading. Just bring it as close as you can to the dotted line, the dashed line as possible, and just shade. Real simple. Okay? So that is my first one. That means that all of these values over here, all these values in the red are true for this equation, and I can prove it to you. Okay? Let's just do a little proof. Let's look at this one right here. What is that coordinate pair? That coordinate pair that I picked is 0, 5, correct? Let's plug that in to our equation, this equation, because it's a inequality. So y is greater than 6x minus 5. What's y equal to? 5. What's x equal to? 0. And there we go. Simplify it. This says 5 is greater than negative 5. Is that true? Yes. And as you can see, all of these points would make it true. Everything that's shaded by the yellow. And that's what an inequality is, okay? But now we're dealing with a system. So what do we have to do? We actually have to do two equations, okay? So let's do this one. Y equals negative 4x plus 7. Well, it's already done because y equals mx plus b. It's in slope-intercept form. So my b is plus 7. My m is negative 4. So my y-intercept is what? You got it. 0, 7. What's my slope? Negative 4. I can make that into a fraction by putting it over 1. So I go down 4 and to the right 1. So let's graph that. 0, 7. Here we go. Here's 0. I get what? 1, 2, 3, 4, 5, 6, 7. So that's the first one. It tells me to do what? Go down 4 and to the right 1. So 1, 2, 3, 4. And to the right what? 1. So that's that. Now, the inequality is a greater than sign. So it's not equal to. So what kind of line are we going to get? You got it. It's going to be dashed. So I'm going to draw a dashed line right through those two dots. And remember that line continues on forever and ever as we go through. Okay. And then draw yourself a what? Vertical line. Doesn't matter where you draw it, just draw it on that line. Okay. Here's the up arrow, here's the down arrow. It says greater than. This arrow is the one for greater than. So I need to shade everything that is above this green line. So I get this whole area. Does that make sense? So where's my answer? You guessed it, where they're double shaded, which is right in this area. So everywhere you see that dark blue is where it's true. The purple makes one line true, the yellow makes the other line true, the double shaded area makes both of these inequalities true. Example number 2. Now, what does this say? That says less than or equal to. So I could do less than or equal to. What's this say? Greater than or equal to. So what kind of lines are we going to get? Solid lines. Does that make sense? So now let's look at this. Y is less than or equal to negative 3 over 4 x plus 6. Do I have to do anything to it? Nope. Because it's already in what format? Slope intercept form. Okay. So my b is equal to 6. My slope is what? Negative 3 over 4. So my y-intercept is what? 0, 6. My slope is what? Negative 3, 4. So go down 3 and to the right 4. Let's do it. So here we go. 0, 6. Here's 0 on the x-axis. Here's 6 on the y. I'm done there. It says go down what? Go down 3 to the right 4. So here we go. We want to go down 3, 1, 2, 3, to the right 4. 1, 2, 3, 4. Now I'll put that. What kind of line are we going to draw? That's right, solid, because it says what? It says less than or equal to, so it's a solid line. So any point along that line makes it true. Now what do we do? That's right, draw that vertical line. It says less than. So this side of the line is what needs to be shaded. So here we go. I'm going to shade this whole area. All of this green area makes this inequality true. Does that make sense? Okay. Now, whenever you're doing it on your piece of paper, don't go crazy with the shading. I understand if you sit there and just make the lines real quick. Boom, boom, boom. Make it go parallel to the line that you drew. Okay. So now, let's do the next one. I have y is greater than or equal to 6 over 7 x minus 2. Do I have to do anything to this equation? No, because it's already in what? Slope intercept form. So here we go. The y-intercept is what? You got it. 0, negative 2. What's my slope? 6 over 7. Go up 6 to the right. How many? 7. So here we go. We want to go to 0, negative 2. So here's 0 on the x-axis. Here's negative 2 on the y. I want to go up 6 to the right 7. So here's 1, 2, 3, 4, 5, 6. 7 to the right. 1, 2, 3, 4, 5, 6, 7. And now I make my dot there. What kind of line do I get? Solid. Why? Because it says greater than or equal to. Okay? And now, since it's greater than, here we go. Put your line on here, your vertical line. Greater than is which arrow? This side. So above the line is what I'm going to shade. Here we go. So I'm literally just going to shade this way. So as I shade, there we go. You can see where they overlap. Where do they overlap? Everything that's right over here. That's nice and dark. Okay? So that's all you have to do for me is make sure that you show me where the darkest, where the double shade side is. It needs to be darker than any other side. I know I'm using colors. If you're using pencil, you have to be able to show where the darker spot is. So all the solution to this system of inequalities is right there. That's the double shaded area. Okay. Example number 3. I kept giving you equations that were what? Slope-intercept form. What are these in? Standard form. What do I have to do? Get it into what? Yeah, that's right. Slope-intercept form. Why? It's just easier to graph, okay? If I put it in slope-intercept form, I know what the y-intercept is. I know what the slope is, the change in rate, and then I can sit there and go from there. Okay, so let's do the first one. I have 8x minus 2y is less than 16. I know something about this. I'm going to get a what? Dashed line. Why? Because of this inequality. Now, what do I want to do? Solve for y. What do I do to solve for y? 4 steps. Simplify / combine like terms. Nothing to do. Step 2, remove all what? Addition, subtraction. I am going to subtract. Subtract what? This 8x. I'm adding 8x over here, so I need to subtract it. What I do to one side, I must do to the other. This cancels. I get negative 2y is less than 16 minus 8x. Step 3, remove all what? Multiplication and division. So I'm going to divide. I'm going to divide by a negative 2. What I do to one side, I have to do to the other. Now, negative 2 divided by negative 2 is just 1, so I get y. 16 divided by negative 2 is what? Negative 8. Negative 8 divided by negative 2 is a positive 4x. You're probably wondering why I didn't write the inequality, because you need to star this. Anytime that you divide by a negative number, okay, a negative number, and there's an inequality involved, you must flip the inequality. Okay, so now it is no longer less than. It becomes what? Greater than. Does that make sense? So since I divided right here by negative 2 and a negative 2, I must flip that inequality. And now I get y is greater than negative 8 plus 4x. Now, if I look at it, I get y equals m. Well, that's not m. It's not, I didn't switch the order around with the commutative property. But let's just write this because I want you to get used to this. Y is equal to what? That's b. And then this is plus mx. Okay, so now this is my b, this is my what? M. X lines up, Y lines up, I'm good to go. Just want to make sure that some people don't get confused, so I like switching it up a little bit. So what's my y-intercept? Y-intercept is what? 0, negative 8, because that's what my b is. My slope is what? 4, so I can make that a fraction. Put it over 1, so I go up 4 to the right 1. So let's go to 0, negative 8. Here's 0 on the x-axis. Here's negative 8 on the y. Okay? It tells me to go up 4 to the right 1. So 1, 2, 3, 4 to the right 1. Good there. What kind of line am I going to draw? That's right. This is greater than, so it's got to be dashed. Okay, so if I'm dashing, I want to go here, 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 here. Make sure you make it long enough so you have a lot of room to sit there and do your shading. Okay, so now, with that being said, what do we make on this line? That's right. You need a vertical line. Why do you need this vertical line? To figure out which side is greater than or less than. Well, we're looking for greater than. So it's going to be this side, the side above the line. And what do? We just shade that side. Notice shading is just quick. It doesn't have to be perfect. You don't have to fill in every square. Just get the shade down so I know what side. Okay? So that's the first problem. What do we have to do now? We got one more. So here we go. I have negative 10x minus 5y is less than, well, greater than or equal to 30. What do I solve for? You got it right. Y. So, simplify slash combine like terms, nothing to do. Remove addition, subtraction, I am going to add. Add what? This positive 10x. What I do to one side, I must do to the other. So here we go. This cancels. I get negative 5y is greater than or equal to 30 plus 10x. Step number 3, we're going to what? Divide. Divide by what? Negative 5. What I do to one side, I must do to the other. So negative 5, I get y. There we go. 30 divided by negative 5 is what? Negative 6. 10 divided by negative 5 is negative 2. Why didn't I write the inequality? That's right. What did I do? I divided by a negative. So always keep your eyes peeled. If you divide by a negative and we're dealing with inequalities, you have to what? Flip the inequality. So this becomes less than or equal to. Okay? What kind of line am I going to draw? That's right. Solid. Because it says equal to. Okay? So y equals, this is b. The 2x, anything with the x, that is always your slope. So plus mx, okay? So here's my b, here's my m, and there's the x's, correct? So my y-intercept is what? That's right, 0, negative 6. Does that make sense? My slope is what? Negative 2. You can put it over 1. I'm going to go down 2 and to the right 1. So now, I know it's a solid line. I need to start where? 0, negative 6. So here's 0. Here's negative 6. It tells me to go down 2, 1, 2, to the right 1. There we go. And instead of a dash line, I'm going to get a what? That's right. Solid line. I get a solid line. Now what do? Without fail, still draw our vertical line. Now, let's go back to the problem. What inequality are we looking for? Less than or equal to. So, which one is it? Top or bottom? It's the bottom. So now I shade everything below this line. Okay, so it's only a little sliver where it's not true for both, but everything else is definitely right there. Double shaded, good to go. And that is my answer for the system of linear inequalities. So linear inequality systems that are what? Parallel. Gotta make sure that we understand what's going on here, okay? Don't want you to be confused. So let's just go ahead and get this on the graph. How do I do this? Well, it's in slope-intercept form. So y is greater than, what kind of line am I going to get? That's right, dashed, because it's just greater than. So y, I got 4 over 5x plus 1. This is already in y equals mx plus b. So I know my b is 1. My slope is what? 4 over 5. So my y-intercept is what? 0, 1. My slope is what? 4 over 5. So I'm going to go up 4 to the right 5. Does that make sense? So let's get that on the graph. Here is 0, and here's 1. And I'm going to do what? Go up 4 and to the right 5. So here we go. 1, 2, 3, 4. To the right, how many? 5. 1, 2, 3, 4, 5. So that's that. What kind of line am I going to draw? Dashed. Why? Because it only says greater than. So I get a dashed line all the way across, okay? Dashed line. Good. Now, draw your vertical line. Remember, you can use the y-axis. I don't mind that. But sometimes you need a little something to make sure you understand exactly what we're doing. So we're looking for what? Greater than. I need a greater than. So this side is greater than. So above the line is greater than. And what do we do above the line? That's right. Just shade it all in. So it happens real quick. Boop, 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 boop. Make sure you get close to the line because sometimes that's the most important part. Okay? So I'm done with one equation. That took all of what? 2 seconds. Okay? So now, let's do the next one. I have y is less than 4 over 5x minus 6. So here we go. Y equals mx plus b. My b is negative 6. My slope is still 4/5. So my y-intercept is what? 0, negative 6. My slope is what? 4 over 5. That means go up 4 to the right what? 5. So here we go. Let's do it. Here is 0. Here's negative 6. Go up 4. 1, 2, 3, 4. Right 5. 1, 2, 3, 4, 5. What kind of line am I going to make? That's less than, so I'm going to make a dashed line. Right there. Now we draw our vertical line on our line right there. That lets me know greater than or less than. I want less than, so I want this side. So let's shade that side. Everything below. Good, 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 good. Now let's look at the graph. Are there any parts of the shading that is overlapping? No. So what does that mean? There are no solutions to this one when it comes to the system. There's nothing that's going to make both of them true at the same time. So example number 2 for parallel lines that are linear inequalities. I have y is less than negative 8 over 9x plus 8. This is already in slope-intercept form. You should be able to recognize that by now. So I know what my y-intercept is. My y-intercept is what? 0, 8. Slope is what? Negative 8 over 9. Go down 8 and to the right 9. Okay? So let's do that. Let's find 0, 8. Alrighty. So here is 0. Here is 8. And I'm good to go. My slope is negative 8 over 9. Down 8. 1, 2, 3, 4, 5, 6, 7, 8. And go to the right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. What kind of line am I going to draw? It says less than, so it's just a dashed line. Okay, so here we go. Dashed line between these two dots. Boom, 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 boom. Draw a nice little vertical line. Doesn't matter where you put it. Okay, I want less than. It's going to be this side, correct? All right, so let's shade all this in. So it will be everything that's below the line would make it true. Notice I just go quick with my shading, okay? Everything below the line. All right, so let's do the second one. The second one says what? Y is less than negative 8 over 9 x plus 2. Again, slope-intercept form. So I know b is 2, slope is negative 8 over 9. So my y-intercept is what? 0, 2. My slope is what? Negative 8 over 9. I go down 8 and to the right 9. So let's find 0, 2. Here is 0. Here is 2 on the y-axis. I want to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And to the right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I put my dot. Now, what kind of line am I going to draw? This is less than, correct? So it's going to be dashed. And since it's going to be dashed, let's do it. So I draw a dashed line all the way through, just like that. Okay, and now it says less than. Let's draw our vertical line. Less than is going to be which one? This one. Okay, so I need to shade everything below the blue line. And as I do it, what do you notice? Everything pretty much is true, except for what? This area right here. That's only true for the green line. But everything else is true for both lines. So the double shaded area is true for both lines. And both of these lines are what? Parallel. Okay? So those are the two types of parallel line equations that you could get. So you can have no solution, or you can have a double shaded area where one part is shaded. That's not true for both lines, but the rest is. Okay?